that being said, let's do a little bit with our inequalities. All right, we should know that this is a less than sign. We should know that this one is a greater than. All right, then we also have less than or equal to. So less than or equal to, which means it can be equal to it, or it can be less than, and it'll make that true. And if we have a less than or equal to, then we would also have a greater than or equal to. All right, so hopefully you've already seen those, you've done them, you've worked with them, you recognize them. All right, you may have a little problem memorizing them. All right, but this one right here, all right, for less than, if you struggle, it would work on this as well, but less than or greater than, all right, that's your less than sign, and it kind of makes an L. So if you have never been given a mnemonic for memorizing this one, you straighten it up, makes an L, so you know this one's less than. Easy way to remember it if you've never had a mnemonic to remember it. Okay, these are read left to right. Okay, so I always read left to right on these. Now let's put some things underneath each one of these. If you have a less than or a greater than sign, when we go to graph these, all right, we will have open dots. So let's do this in a different color. So for these, I'm going to have open dots, and that's probably what you used in middle school. All right, we're also going to start introducing interval notation, which means we're going to use curvy brackets. So where you always used open dots, we're also going to show you what it looks like with interval notation and curvy brackets. That should be new to you. All right, now these have the equal to part, which basically means the number that you're in question is going to be an answer. It's going to be a solution. So this is where you used closed dots in middle school. All right, and since we're going to introduce this idea of interval notation, we're going to put square brackets. Okay, so we're going to do the open and closed dots just like you used in middle school, but then we're also going to do the number line this way. So that way when the questions come up in Math Excel and it's in interval notation, you're going to be able to transition between your open and closed dots and your curvy brackets and your square brackets. Okay, now let's take a look at, like I said earlier, when you solve an equation, we got one answer, right? And we solved that equation, and maybe it was x equals 8. All right, maybe that's what the answer was after we solved it. It could have been an equation that was two-step equation. It could have had x on both sides, could have had distributive property, whatever. We get x equals 8. If I were to graph x equals 8 on a number line, I would be just doing one spot. Here's the 8. On the right-hand side, 8 is 9. On the left-hand side is 7. All right, there would be no reason to start at 0 and make 8 little hash marks, especially if that answer was like 100. You don't want 100 hash marks. Put that in the middle of your number line. All right, wherever it's at, put a couple numbers on both sides so that you know, so that I know you know how to draw a number line. All right, that's the only answer. We would put a solid dot on 8, and that's all you do. All right, so we don't graph equations when we solve them because it's only one answer, and that'd be kind of dumb. Draw a bunch of number lines, put single dots on them. Stretching? Yeah. Okay, I thought you had a question. All right, now, on the other hand, you should have in middle school, let's say if you solved something and you had x is less than 8, that means 7 works, 5 works, 4 works, 3.5, 2.1. All right, any number, decimal fraction, or anything less works. All right, so the way we're going to shade this and the way you did it in middle school, again, whatever that number is, put that in the middle of your number line so that you don't have to draw a great big huge long number line. So put your 8 in the middle. 9's going to go on the right, 7's going to go on the left. All right, now if it's a less than, in middle school you did open dots? Please tell me you did this in middle school. Yeah. Yes. Okay, so you put an open dot right there on the 8, and then x is less than 8, so then you ask yourself, okay, where are the numbers that are less than 8? Well, they're all the numbers over here, and it's not just the 7 and the 6 and the 5, but it's 7.5, 7.2, 7.1. It's all of them. So then I want it shaded. Now, I didn't do that above the number line. I did it on the number line. If you do this by hand, that's the way I want it to look. All right, a lot of people, I see a lot of this, they do an open dot here and then they draw it above the number line. All right, let's not. I want it on the number line, shaded really dark, just like that. Now, I said we're going to introduce interval notation. An open dot is the same thing as a curvy bracket. So, let's put this in blue. It is called interval notation. And this should be brand new because you haven't heard of any of this, okay? All right, I'm still going to draw my number line. I'm still going to put 8 in the center. I'm going to put 9 on the right-hand side and 7 on the left-hand side. All right, but instead of doing the open dot, because I know an open dot means the same thing as curvy brackets, I'm going to put a curvy bracket on the 8, which means I'm not including the 8. That's the exact same thing. Okay, you just have to get used to new notation. And it still means all the numbers that are less than 8, so I'm still going to shade everything to the left of the 8. Okay, so some of the questions you see in Math Excel are going to use the open dot. Some of them are going to use the curvy bracket. All right, it's just different notation, but they mean the exact same thing. Okay? Did you do interval notation in Algebra 1? Did you guys do it? Okay. All right, now let's do another one. All right, actually, let's do several more because there's lots of ways I can do these inequalities. All right, so like let's do another one. Let's suppose I had x is greater than or equal to, let's do a negative number, a negative 3. All right, if I asked you to put that on a number line, again, negative 3 is not very big, but don't start at 0. Put negative 3 in the middle of your number line. All right, if negative 3 is in the middle, Griffin, what number is going to come to the right? One that's negative 2. One that is bigger. And then to the left then would have to be the negative 4. All right, now it's got the equal to part. Okay, so if it's got the equal to part, is it going to be a closed dot or an open dot? Closed dot. So I'm going to put the closed dot. All right, and then you ask yourself, read the sentence. X is greater than or equal to negative 3. Where are the numbers that are bigger? Are they on the right or are they on the left? They're on the right. So I want the number line shaded in, not above it, right on top of it. All right, so if you see it with an open dot, that's fine. All right, if we were going to do it in interval notation, the exact same answer would have a square bracket. If it's a closed dot, it has a square bracket. So literally, I would make the square bracket go the direction that I'm going to shade. So there's my square bracket. And then I would shade to the right. All right, and it's really important if you've not seen the square brackets and the curvy brackets or that interval notation, I want you to recognize that this and this is the same thing. Because when I pick the questions in Math Excel, I'm going to pick both. I'm going to pick some that have open dot, closed dots. I'm going to pick some that are using the curvy and square brackets. Okay, now so far, every inequality that I've given you, we've just shaded one way or the other. All right, that's not the only thing we can do. We can do some that are compound inequalities. I could do something like a negative 6 is less than an x, which is less than or equal to an 8. All right, it's a compound inequality. All right, but we should be able to graph this pretty simple. Okay, let's do open dot, closed dots first. All right, there are only 2 numbers in the problem. Those are the 2 numbers that need to be on your number line, and I don't care how far apart they are. Those are the 2 numbers of interest in this compound inequality. So put 1 hash mark over here, negative 6. Put 1 hash mark over here, 8. All right, this will be written least to greatest, has to be written correctly. So this number has to be smaller, has to be on the left. That one has to be bigger. All right, now this sign, think of this sign going with the negative 6. Think of this sign going with the 8. Okay, so what type of dot's going to go on negative 6? Open. Okay, so we'll put an open dot. All right, what kind of dot's going to go on the 8? Closed. Now, where is the x in relationship to the 2 numbers? The x is in the middle of them, so we're going to shade in the middle. And again, watch how I'm drawing on this number line. Literally, I'm on the number line. I'm not drawing it above the number line. Okay, I'm literally drawing it on the number line. Okay, so pretty straightforward. All right, now if we chose to do it in interval notation, the open dot corresponds to curvy, the closed dot corresponds to square brackets. So it would look exactly the same except for what's on the number line. I would put a nice big curvy bracket on the 6, -6. I would put a square bracket. Again, my square bracket is going to face the way I shade. I'm going to shade in the middle. Okay, so the open and closed dot, which you were first introduced to, now the interval notation, and these mean the exact same things. All right, so we think we got that because that's pretty straightforward. All right, now what you're going to have to do, they're only going to do one-step inequalities where you have to shade, solve, and then shade on a number line. Okay, so we'll do a whole setup. And you've got to start paying attention to the directions because sometimes it's going to say solve, sometimes it's going to say solve and graph. We're not getting laptops out yet, guys. Put laptops up. We're still taking notes. All right, so you're going to have to pay attention to the directions. Now, in Math Excel, what it may do is it may say solve and graph, but then it's going to, you're not going to get the graph part until you answer the first question. So it's going to tear it down in part A, part B, part C. All right, so let's do one-step, two-step equations. And we can only do add or subtract. So let's say this says x minus 4 is greater than -9. And it's going to say solve and graph. It's a one-step equation. We've been solving these one-step inequalities here. All right, so what am I going to do to both sides? Xavier, what do I want to do to both sides? Yep, I'm going to add 4 to both sides. So I almost write a 5. I don't know why I did that. All right, -9 plus 4. -9 plus 4. Layla, what's that? -5. So I've got x is greater than -5. All right, you can't just circle the -5 on these for your entire answer. This entire thing is the answer. All right, so just if you are doing this on paper, pencil, if we have to do like 10 questions at the beginning, all right, you're going to do it. Circle the entire thing. All right, now the graph part. What number goes in the middle? Noah, what number goes in the middle? -5. All right, number on the right. Chris, what number goes on the right of -5? A -4. And on the left, -6. Okay, what kind of dot? Braden, what kind of dot? Open or closed? Open. All right, which way am I shading? Griffin's smiling at me like, please don't call on me. Griffin, which way am I going to shade?
Left.
Okay, x is greater than.
Never mind, right.
Going to shade to the right. Okay, if I chose to say solve and graph using interval notation, what's the only difference? Jai, what's the only difference? I'm going to have the curve on the -5. That's going to be the only difference. All right, so if it wants interval notation, the number line is going to be the exact same thing. -5 here, -4, and a -6. And I just make a nice big curvy bracket. I still shade to the right, and I still shade on the number line. All right, I know in Math Excel you're not having to draw these graphs, okay? But we do enough paper pencil stuff, all right, on worksheets or whatever at the beginning of the class that you've got to be able to do it by hand as well, okay? I think solving graphs going to be the only thing. Now, I do want to address, everything so far has been integers, all right? Every answer, everything that we've done, every example has been an integer. All right, when you do this by hand, I want you to know what to do when it is a rational number. All right, so let's do this. Let's put a little double star because this is important. Let's say hash marks on a number line can only be integers. Okay, because I'm going to draw a pretty big number here, number line here. 0 would be in the middle. 1, 2, 3, -1 over here, -2, -3. All right, these are hash marks. These things right here are hash marks. And when we draw a number line, that represents the set of integers. Okay? If I want to show a 1.5 or a 1/2 or some fraction, if I want to show something in the middle of this, I don't want to put a hash mark on there. All right, let's say it said to graph, we'll make it really simple here, x is equal to a 1/2. If I was going to graph that, well, first of all, where is a half? It's in between what two numbers? It's in between 0 and 1. All right, I don't want to make another hash mark. I don't want you to make another hash mark. If you're doing this by hand, all I want you to do is do a rough estimate, put your dot halfway in between, and then label it 1/2. Don't put a hash mark on it, all right, because our hash marks on that number line are our integers. All right, if I was going to graph, maybe say x equals, let's do -1 and 3/4. Let's do that one. Okay, -1 and 3/4. Okay, first of all, what two numbers is that in between? -1 and -2. Now, is it going to be closer to the -1 or is it going to be closer to the -2? It's going to be closer to the -2. All right, that would be about 3/4 of the way. I mean, we're doing a rough estimate. That's all I want you to do. Rough estimate, put a dot there. -1 and 3/4. Okay, so if you happen to get answers that are mixed numbers or decimals, just when you draw your number line, do it this way. And then if that was less than, couldn't I have put the dot, estimated the dot right there, put these two on here, and then just shaded to the left? All right, so don't put hash marks on there if you're doing this by hand. All right, so that's about the only thing I want to do. Let's do a great big, let's let you do a great big long distributive property inequality, and let's let you solve it and graph it by yourself. Okay, so I'll give you a moment to do this. I want you to solve and graph. Let's graph with open closed dots and interval notation. So I want two number lines when you do this one. All right, two parentheses. 3x plus 2 plus 7x is less than a -10. All right, we're going to do more than just one step because we know how to combine like terms. We know two-step equations. So solve it first, circle that answer, draw two number lines, one with open and closed dots, one with interval notation. Before you can do the number line, you've got to be able to solve first. All right, you've got to be able to do distributive property, combine like terms, and solve all the way down to x on one side. All right, we got about 3/4 of you done. Okay, all right, so watch for a minute. Your steps on solving this should match my steps. Okay, we've got a 2 and a set of parentheses. We know that this means distributive property, so that 2 needs to be multiplied by the 3x. The 2's got to be multiplied by the other 2. So 2 times 3 is 6x. So everyone ought to have a 6x there. 2 times 2 is a 4. Then you ought to have a 4. The 7x we're not doing anything with, so it comes straight down. The less than sign comes straight down. The -10 comes straight down. All right, we know how to combine like terms. There's a 6x and there's a 7x, and they're being added. So then you would add 13x. We didn't do anything with the 4, so in the next step your plus 4 would come down. Then you're going to have a less than, then you're going to have a -10. All right, at that point you've got a two-step equation, except it's an inequality, but it's the same thing as if there was an equal sign there. All right, so at that point what do? We subtract 4 from both sides of the equation so that these 4's go away. Then we get a 13x, the less than sign comes down. -10, -4 is a -14. All right, then you have to keep going, right? Because x has to be by itself on the left-hand side. So then we divide by 13, and we divide by 13. All right, so then we're down to, and then that is an improper fraction. So I would look at it as if it was negative 14 over 13. 13 goes into 14 one time, so negative 1 with 1 left over. All right, so this is one of those where it's going to be in between two numbers on your number line. That right there is the entire answer. All right, you're supposed to do two number lines, one with open closed dots, one with the interval notation. So over here, we'll do the open and closed dots. Over here, we'll do the interval notation. This is in between what two numbers? Yep, so negative 1 goes here, negative 2 goes here. All right, and 1 over 13 is going to be closer to the negative 1, right? So rough estimate, is it going to be open or closed dot? Look again. Open. So open dot, we'll just estimate it. Somewhere in there approximate, it's okay. Is less than, so numbers on the left or numbers on the right? Where are the numbers that are smaller? Which side? Left. Someone said left. Okay, because as you go left on the number line, they get smaller. Okay, so then I would shade over here. So that's what the number line looks like with the open and closed dot. You do the exact same thing for the interval notation one, except, am I going to use a square bracket or a curvy bracket? Curvy. So again, you estimate about where it's at, and then you shade to the left.